Do you hear that? That's the sound of powerful destruction. The sound of Molecule's air-purifying pico-technology safely dismantling pollen, mold, viruses, bacteria, and chemicals at a molecular level, leaving behind crisp, clean air. Anyone can filter. We destroy. Find the Molecule Air Purifier for you at molecule.com.
Now that everyone's here, welcome to How to Minimize Indoor Air Pollution, a panel discussion with leading researchers. Thanks for joining us. We're going to discuss some of the newer research around indoor air quality and some possible ways to think about improving it. With us today is Dr. Philip Stevens, a Rudy professor at Indiana University. Dr. Stevens earned his PhD at Harvard in physical chemistry and is a leading scholar in atmospheric chemistry with many publications to his name. We invited him here to speak about indoor air quality and what practical information recent research into the chemistry of indoor air might be able to tell us. Thanks again for agreeing to participate. We also have Dr. Eric Labelle, who is a senior scientist at PSA Healthy Energy and earned his PhD from Stanford University in environmental earth system science. His research is focused on methane, natural gas, and harmful air pollutants in California. We invited him here because he has done some great research into how our air changes during indoor activities like cooking and how that impacts our communities on a much larger scale. Thank you for being here, Dr. Labelle. We really appreciate both of your insights here today. We also want to thank ISSA and the team over there for helping us put this together and also for being champions of healthy indoor environments. ISSA is dedicated to illuminating the scientific links between cleaning and health, similar to my organization. My name is Haldane King, and I am the head of science content at Molecule, that's Molecule with a K. In addition to bringing innovative air purification technology that addresses a wide array of indoor pollutants to the market, we are also on a mission to bring clean air to everyone. Part of that mission is to host events like these where we can spread information about indoor air pollution from qualified experts. And as you are all likely aware, part of this panel will involve a contest for two people to possibly win a Molecule Mini Plus. Whoever answers two very easy science questions that will be informed by our discussion in the chat first wins. Molecule Mini Plus is our purifier designed specifically for bedrooms that features simple air quality tracking. The contest will happen towards the last third of the panel, so be sure not to miss that. So let's turn to our panelists. Excuse me. So Dr. Stevens, what initially drew you to air quality research?
Well, I guess it began when I was looking for graduate schools. I was visiting various programs and then visited Jim Anderson's lab at Harvard, who at the time was launching balloons into the stratosphere to understand stratospheric ozone chemistry. And that just became hooked while I was a student at Harvard. Jim's group made the measurements that proved that chlorofluorocarbons were responsible for the ozone hole. And I did some stratospheric chemistry work. Then when I started my own research, I kind of moved down from the stratosphere to the troposphere and started making measurements of free radicals in the lower atmosphere. And so we are one of about 4 groups in the US and about a dozen worldwide that are capable of measuring the hydroxyl radical and peroxy radicals in real time in the atmosphere. And so we've been doing a lot of outdoor air quality measurements. And it was several years ago at meetings, Charlie Weschler, who many of you may know, who is a leading indoor air expert, convinced me that we needed to make measurements of radicals indoors because nobody had really done it. And at first I was skeptical because, well, you know, the radicals are produced by ultraviolet light and we don't have a lot of that indoors. But I agreed to, and we participated in the recent Home Chem campaign where we measured radicals as well as nitrous oxide and, HONO, nitrous acid. Surprisingly, we saw very active radical chemistry inside. And so with support from the Sloan Foundation, we have done additional measurements of indoor air during cleaning and cooking episodes in a variety of indoor environments. And to be honest, it's actually a lot more interesting than I thought it was going to be. And so I think we're going to be continuing these measurements for a while now.
That's great. So with ozone, that's kind of a success story there, right? I mean, I feel like the or at least some CFCs have stopped being produced and that kind of thing. That's awesome. And then with free radicals indoors, we'll be getting into that a little bit more later. But that's kind of a significant finding. Like we didn't really think there were free radicals indoors, or if so, that they really did much, right?
Right, that's correct. I mean, I think like I said, I was skeptical that we would see any measurements of hydroxyl radicals indoors. And even some of my colleagues, when they first showed me some of the initial measurements from VOCs and things during home chem, they said, oh, you're not going to see any radicals. But the truth is that even though there are a lot of volatile organic compounds in indoor environments, there's also high concentrations of nitrogen oxides, and that can sustain the radical concentrations indoors under different conditions.
That's really important to figure out. So is this kind of what led you to the projects you're currently working on?
Yeah, so we, with support from the Sloan Foundations, we are doing measurements of radicals in different indoor environments. We recently published a paper where we cleaned a typical office building in a real, basically real indoor environment, as opposed to a chamber or other might be considered indoor environments. This is a real office. And in collaboration with Brandon Bohr's group up at Purdue, he made measurements of the radicals, ozone, nitrogen oxides, and particle formation during where we just mopped with a commercial cleaner. And we found that in this particular office, the concentrations of reactive VOCs, mainly limonene and other monoterpenes, reacted with very small concentrations of ozone that we measured in the room. In fact, we could see the ozone go down from about 5 ppb down to 1 ppb during the mopping episode. Monoterpene concentrations exceeded ambient outdoor concentrations by several orders of magnitude. And then we saw new particle formation that when we did a dose rate study, basically the inhalation dose rate was similar to what someone standing in an urban street canyon exposed to exhaust from automobiles and other sources outdoors would receive the same dose of small particles during the episodes. And of course, that's a health risk. We don't know a lot about the composition or the toxicity of the particles, but the fact that we could make them very quickly and in very large concentrations was somewhat surprising.
Yeah, it's concerning. We'll talk a little bit more about how that tends to happen and maybe what people can do about it. So after your time in the field so far, do you have any one more like something that you'd want to, do you think is most important about what you've learned so far, that something you'd really want to share with people that you don't think everyone is really aware of quite yet?
Well, I think at least I was never aware of the ability of some of our indoor activities to oxidize and create particles, as well as other secondary oxidation products. And so at least in my own home, we are reducing the use of various cleaners and things that I know contain these reactive molecules. And so, yeah, I think we need to be a lot more aware of the type of VOCs that are being emitted, as well as nitrogen oxides and other emissions that are occurring inside.
Yeah, we'll be getting into that a little bit more in just a moment. But first, let's talk to Dr. Labelle a little bit. So, Dr. Labelle, what drew you to air quality research?
Yeah, I would say that my journey with air quality research began with an internship I did with NASA, where we got to fly on a one of their DC-8 aircraft that they have hooked up a bunch of air quality sensors and have the ability to take whole air samples from outside the plane. So we're able to use these analyzers and grab samples of air and analyze it for air quality across the Southern California during this research campaign. And it really opened my eyes to the importance of doing air quality research, particularly outside, and how it's very beneficial to really understand atmospheric chemistry and understanding why air quality matters in a pollution-stricken region like Los Angeles, for instance. So then I did my graduate studies at Stanford University, where I worked looking at methane emissions in California. So methane emissions, we could talk more about this later as well, but it has a great impact on the climate change problem. Methane is a very strong greenhouse gas, even more so than carbon dioxide. And so one of the things that we looked at was what sources of methane can we find across the state of California that haven't been accounted for yet. And among other things, this drew me to looking at buildings and gas appliances in buildings. Natural gas is mostly methane, it's more than 90% methane. And we measured the methane emissions from different appliances in buildings like water heaters, stoves. And when we measured the stoves, we also realized that not only do the stoves have a climate impact from the methane emissions that they emit, but there's also an air quality component as well, because stoves are typically inside people's homes. There's not necessarily a dedicated vent for each of the stoves that turns on automatically. And even if there is, people don't necessarily turn it on, or it recirculates the air back into the kitchen space, making it a bit less effective than if it exhausted the air directly outside. So we also wanted to take this opportunity while we were measuring stoves to also look at the indoor air quality components of the gas stove and how that would affect indoor air quality.
Right, because up until now, people didn't really think of methane as like toxic or like something that you wouldn't want to have in your home, right?
Yeah, and just to be clear, methane itself is not the issue in terms of indoor air quality. It's what else is in the gas and what else is being produced when you burn the gas. So methane, the only time it would be a problem is if it reached such levels that it would be asphyxiating, if it displaces enough oxygen, or if it becomes an explosion hazard. But it's not going to be detrimental to human health on its own. But we at research at PSC, now I'm a senior scientist at PSC Healthy Energy. We're a nonprofit research institute that studies the energy, environment, and public health. And one of the studies that we recently published looked at the other constituents of natural gas besides methane. Methane was thought, natural gas was thought to be primarily a clean fuel. And while it is mostly methane still, we have found that there are, in fact, other VOCs present in unburned gas.
It's really interesting. So, and then I think that's on your paper. So it's not just the unburned gas and the VOCs. It's also a little bit about the nitrogen and the other kinds of things that arise from the burning of the natural gas, right?
Yeah, exactly. So when you burn natural gas at a stove, so there's one of the things that we measured directly as part of the research I did at Stanford was emissions of NOx from a stove. So NO and NO2. Nitrogen dioxide, NO2, is primarily a respiratory irritant. I'm sure we'll talk more about this later, but we measured that directly from gas stoves and measured the emission rates of NO2 from the gas stoves. And what we found was that the more burners you use, or the higher you turn the burner on, or if you use more than one burner at once, you can generate higher levels of NOx inside your kitchen. The rate of emissions from the stove is directly proportional to the amount of gas that you're burning. So it's most important to think about in terms of people who use their gas stove for a lot of cooking, and also for people who tend to have smaller kitchens or poor ventilation inside their homes, because in those situations, the concentrations of NOx will build to more harmful levels at a quicker rate.
Yeah, I mean, we always hear from the EPA and from many other sites that they say things like indoor air is 2 to 5 times more polluted than outdoor air. But in this case, it seems like it would get more than 2 to 5 times more polluted if it was these, pollutants were allowed to build up there.
Yeah, and that certainly depends on your certain circumstances inside your house. If for instance, if you have like a really highly energy efficient house that's really tight and doesn't have as much of a ventilation because you're trying to save heat energy in other ways, by keeping your house tighter, then in that circumstance you'll have less ventilation to exhaust these pollutants out of your house once they enter your kitchen when you're using your gas stove. In other circumstances, like if you're living in a smaller apartment building, for instance, that has a really tiny kitchen, or you have more housemates that are using the gas stove more frequently, these will also be able to cause higher emissions of NOx from the stove and result in higher concentrations inside your kitchen. Yeah, it's a combination of the rate of emissions from the gas stove, and then in combination with the size of your kitchen and the ventilation in your kitchen.
Yeah, I mean, it sounds like having a source of air pollution inside your actual house is can be fairly detrimental.
Mm-hmm.
Well, thanks for that, Drs. Stephen and Labelle. I think we're going to move on to our next topic here, which is this thing that Dr. Stevens already mentioned a little bit, which is VOCs. It's not the easiest term to remember. Not a lot of people understand. It stands for volatile organic compounds. You kind of need to remember all of your high school chemistry to even know what all of those things mean. So, Dr. Stevens, how can we better explain how to think about VOCs? I mean, I know there's lots of different sources of them, but we just got a question about Glade plugins, for example. I mean, are those are, I know those are sources of VOCs, but when we think about sources of VOCs in our houses, which are the ones that we should be more concerned about? I mean, or just in general, we should be wary of these chemicals.
Sure. So there are a variety of different volatile organic compounds that are present in the home. There are some that are not very reactive and may not be toxic. Emissions from carpets and furniture and things like that. But then there may be some that are toxic, like the flame retardants and things like that we have to worry about. But there are a lot of people studying those concentrations indoors of what you might call persistent organic pollutants. But one thing that we don't know a lot about is the reactivity of these volatile organic compounds and how they could lead to, if they themselves may not be toxic, in an indoor environment, they may be able to be oxidized to produce compounds, ultimately things like formaldehyde and other things that are more toxic than the emissions themselves. And so, we're aware about the reactivity of a lot of these compounds outdoors, but outdoors, we know we have a lot of oxidants. We have ozone, ambient ozone concentrations that are higher outdoors than they are indoors. We have hydroxyl radical concentrations, which can oxidize VOCs. And concentrations outdoors are generally higher than indoors. But what we're learning is that some of these reactive emissions, even with low concentrations of ozone, are so reactive with ozone that they can, again, produce oxygenated products, which then they themselves be toxic, but also can lead to particle formation. And outdoor particle formation, PM 2.5, PM 10 are regulated for health impacts, but they're not regulated indoors. And as I mentioned earlier, we have seen similar particle production, similar sizes, and similar dose rates when we're doing just cleaning with a commercial cleaner that we got at the grocery store. These compounds that are the most reactive tend to smell nice. So I mentioned monoterpenes. Limonene is probably the most common one. It has a nice citrus scent, and it has some cleaning properties that it can hold as a solvent. It can hold grime and grit a little better, but it's very reactive with ozone. And that then leads to the oxidation indoors. And so I think what we need is to, basically understand what is the reactivity of these VOCs that are being emitted. Now, the Glade plugins, my wife used to use them too, and as well as essential oil diffusers. And she would say, oh, well, they're natural. And I was like, sure, they're natural, but they're natural outside, but they may not be natural inside. And natural emissions do oxidize in the atmosphere and form particles. And these plugins that they may make the house smell nice can lead to particles and oxidation depending on their concentrations and the amount of ozone in the house. And again, that will vary from household to household depending on the air exchange rates and the type of filters that are used in the house that may be able to remove particles as well as ozone. But what we found in our study was that just a typical air exchange rate that you might find in mainly an office building could produce particles. Even a fairly high exchange rate, the reactivity was so fast that even with the high exchange rate, we were able to generate high concentrations of particles as well as these reactive VOCs. My wife doesn't use the Glades plugins anymore, and we recently went to visit family in a wedding, and we rented an Airbnb. And as soon as you walked in, there was the smell of the Glade things was there, and I had to go searching through the house to unplug all of them because I didn't know what the ozone concentrations in the house were, and I didn't know what the impact would be.
Yeah, because I mean, the limonene, like you were saying, is literally the smell of lemons. So like anytime you have like a lemon scented, dishwashing soap or a floor cleaner or whatever, like that's almost certainly has a ton of limonene in there, and it shouldn't harm you. I mean, I guess some people might be allergic to it, but it shouldn't harm you. But what you're saying is that when it gets oxidized in the environment, and oxidation happens with ozone and with some other pollutants, but that means the VOCs are sticking together and they're creating particles, basically, right?
Right. So what happens is, limonene itself may not be toxic. It smells nice and everything like that, but it's very reactive with ozone. It has basically double bonds that ozone likes to attach to, and then that product then decomposes. What you end up with is oxygenated compounds. So limonene itself doesn't have any oxygen on it, but after it reacts, it becomes oxidized, and that generally reduces the vapor pressure of the products, which then allows them, makes them more amenable to condensing to forming particles. And so these particles are going to be highly oxygenated as well. And we call them secondary organic aerosols, but they're highly oxygenated, and their toxicity really isn't known. But what we do know is that small particles, when you inhale them, can get into your bloodstream and cause both respiratory and other health impacts.
Yeah, that was me. But the next thing I wanted to point out is that because these particles are forming from individual molecules, they're incredibly small, and the smaller particles are the more less healthy particles.
Right. Exactly. Yeah. We would see very small sub-nano particles form in these studies that then grew to larger particles, but still on the order of what we would call fine particles in terms of regulatory aspects.
Yeah, it's really interesting to find that out, and yeah, it's especially as we've been sealing our houses up a little tighter over the past couple of years for energy efficiency, like Dr. Labelle is saying, it's really starting to cause some other issues. So moving on to our next topic, this is a question more for Dr. Labelle. We're big fans of his research at Molecule, and we've had some very lively conversations on social media when sharing it out. So gas stoves use natural gas, aka VOCs. Natural gas is VOCs to produce heat. So what is you already mentioned some of the research. So what are the issues that can come along with using natural gas indoors? I mean, we have methane indoors. There's going to be these nitrogen particles. Is it a level of particles that you're going to be likely to, a level of nitrogen oxide that you're likely to be exposed to, like on the street, is it going to get dangerous quickly when you're burning natural gas?
Yeah. So let's talk about the nitrogen oxide for a minute. So the the concentrations that we saw inside kitchens. So in some circumstances, we're able to exceed the outdoor limit for NO2. So there are no indoor nitrogen or nitrogen dioxide standards, but the EPA has provided a 1 hour outdoor standard of 100 parts per billion. And what we were able to find was that the NO2 levels inside the house, just by using your gas stove, were in certain circumstances able to exceed that limit just by turning on a burner and or oven.
Is it the same kind of thing with gas heaters? Did you look at that at all? Yeah, don't know. Go outside your
yeah. Yeah, no, so the gas heaters would be burning it's the same combustion reaction that's going on in a gas heater as would be in a gas stove. The difference with the heaters is that they typically have, or in almost every circumstance, is that they're either already are outside, or in your attic or in your basement or in your garage, and they have a dedicated vent so that the combustion byproducts will automatically travel outside the house. As I mentioned before with the gas stove, it's inside your kitchen. If it does have a vent, it may not vent directly outside. It may just recirculate the air back into your kitchen. And even if your gas stove does have a vent, it's up to the user to turn it on whenever they're cooking. And what other research has found is that people only will turn on their gas or exhaust hood when they're using their gas stove about 1/3 to 1/4 of the time, citing reasons such as it being too loud, or they forget to turn it on, or they don't feel like they need to because they're not cooking anything that smells like smoke. And what we found is that when you have a gas stove, it doesn't matter what you're cooking. Anytime that flame is on, you want to make sure that the exhaust hood is also on to vent the byproducts of combustion outside the house.
Yes, I've been reminding my wife to turn on the vent quite a bit lately since reading your paper. In comparison to something like car exhaust, what are is it a similar health impact to being exposed to the stuff that's coming off of the gas stove?
Well, it's similar in that we're talking about similar compounds, but you want to think about the environment in which you're using these things. Like, you're not going to run your car inside your house. That's dangerous for many levels, and including the NOx levels. But again, it's also a combustion reaction, so you're getting the same byproducts, but on a very different scale, right? With the gas stove, it's even though it's a smaller combustion reaction, it still is literally burning a fossil fuel, right? It's basically humans' most intimate connection with climate change. If you think about it, you're in your kitchen cooking, doing something that humanity has done for ages, cooking over an open flame. And in order to achieve that, we're burning a fossil fuel in order to do it, which has all the health impacts and the climate impacts that we've talked about already. And so, to compare it to car exhaust, I think is it's similar to say that we're talking about a similar combustion reaction, but the circumstances that you drive your car outside, and the cars will have an impact more on outdoor air pollution. Then the stoves will have an impact mainly on indoor air pollution.
So you're saying that ventilation is kind of the only cure here, right?
It's one of the cures. If you're a gas stove owner and if you want to improve your indoor air quality, that's one of the things to definitely keep in mind, is to always turn your exhaust hood on anytime that you use your gas stove. If you don't have an exhaust hood, or if it recirculates inside your kitchen, the next best thing to do is, if the season allows it for temperature outside, you can open your window while you're cooking, and that'll provide extra ventilation inside your kitchen while you're cooking. This also ties in the outdoor air pollution too, because when you open your window, you're also going to be letting in outdoor air. And so we want to assume that the outdoor air is going to be cleaner than the indoor air, in which case it mostly is. The EPA cites that the indoor air is usually 2 to 5 times more polluted than outdoor air. So opening the window is generally a good way to increase the ventilation, especially when you're using your gas stove. Another thing you can do if you have a gas stove is nowadays they sell countertop induction units that you can get. So you can get one of those. I've seen people who have done this before, where they'll substitute out basic cooking tasks like boiling water or something, something that's not a major cooking process, where they'll they'll use this countertop induction unit as a substitute for using their gas stove when they're only trying to do a basic cooking task. Any sort of electric cooking appliance will not have the same pollution from using the gas stove, although depending on what you're cooking, you may get additional pollution emitted from what you're cooking. Is particularly relevant when you're like frying food, for instance, or searing stuff, that you'll get more pollution from that. But that'll happen no matter whether or not you're using your gas stove or whether you're using an electric stove. The electric stove will just simply eliminate the pollution that you get from that open flame.
Yeah, I mean, I was in the home chem series of studies that Dr. Stevens said he was involved in. I did see something that said you're turning on just even a like a regular electric burner can incredibly increase the amount of particles in there. You know, almost 1,000x in a relatively short amount of time, which is important to know. So moving on to our next thing here. So I wanted to compare indoor and outdoor air quality a little bit. We've talked about it a little. Outdoor air pollution has been the focus of most air quality stuff. And so we've heard a little bit about how ozone from outside can come in to interact with VOCs inside and to make indoor pollution worse. So in general, is outdoor pollution, is the outdoor air cleaner than the indoor air? Should we be allowing as much outdoor air into our spaces as possible to dilute what's happening in there?
I guess I can start. I think yes, but with caveats. I think in terms of some of the things Eric's talking about in terms of reducing your nitrogen oxides from gas stove, yes, I think ventilation is going to be important. Ventilation will help reduce other VOC concentrations in the house. But at the same time, it would let more ozone in. And so I think, again, if the VOCs inside, even if their concentrations are reduced by ventilation, increasing the concentration of ozone may offset that decrease in terms of their reactivity. And so I think, ventilation is important, but ventilation perhaps that also involves filtration to help remove ozone and some outdoor particles and things like that. So yeah, yes, ventilation is important, but with caveats.
Okay. Dr. Labelle, you have anything to add to that?
Yeah, I would just reiterate that makes definitely ventilation is the key here in order to reduce the indoor air quality or improve indoor air quality. However, that's not to say that we shouldn't care about outdoor air pollution as well. We have the World Health Organization states that 4.2 million deaths occur each year attributed to outdoor air pollution. And if indoor air pollution is even worse than that, then that number could be even higher attributed to indoor air pollution. So in order a good place to think about starting too even would be is simultaneously while we're thinking about improving indoor air, we also want to think about improving outdoor air as well, which has its own challenges and things that we can do in order to help improve outdoor air.
Yeah, absolutely. I don't know how to follow up for that, but now I can't quite remember what it is. So I think that we are just going to take a short break right now and move on to our contest for our two mini pluses. We're getting a lot of questions here too, so that'll be good for our Q&A session in a little bit here. So let's, if everybody who's on the call, please take a look at your chat. We'll be posting the first question in just a moment, and whoever answers it first, there it is. Whoever answers it first will be able to win the mini plus. There's four choices there, as you can see, and I think that. That Kimberly Wilson may have won this with rusty nails. Rusty nails are not a good source of VOCs. A new car is going to release the new car smell you're all familiar with. Lemon scented dish soap is going to have that limonene in there. An open bottle of wine is going to release ethanol and all different kinds of stuff. And nails are just rusty, and they've already released any kind of VOCs that may have been stuck to them a long time ago. So congratulations to Kimberly there. And so let's post our second question. There are 4 choices there as well. I think you guys should be able to get this one. There it is. Let's see here, Tina and Bill Brown, either Tina or Bill answered ozone first, just barely beat Ted Stark there, but did manage to win. So those will be our 2 winners for the Molecule Mini Plus. Thank you so much for participating. I'm so glad that so many people got the correct answer there, and that everybody's listening to our brilliant scientists here. Okay, so our next section here is just a little bit about kind of how to address and like what is out there right now to address current indoor air quality. There are professionals to handle most of our major issues. There's no doctors or lawyers to call up for indoor air quality. And there are these green building standards like LEED or WELL, and they have all these requirements to meet and things to test and particles to look at and whatnot. But there's only tens of thousands of LEED buildings out there and a few thousand WELL buildings out there compared to the untold millions of indoor spaces that exist. So could either of you make any suggestions as to simpler ways other than complex standards that the average person or the people on our call here could keep aware of the latest ways to improve air quality?
I can jump in first. Just to reiterate what we've talked about so far is the first thing we want to think about is ventilation, right? That's the big thing that we can do in order to improve indoor air quality, especially as buildings are getting tighter and tighter. I think that the big theme that we're hearing a lot of nowadays too is electrify everything, right? We talked about this a lot already in terms of your gas stove, but the other appliances in your house as well are also, if they use natural gas, they're going to be burning fossil fuels at the site of the appliance, and they'll be reducing or emitting pollution and carbon dioxide and perhaps methane into the atmosphere. And depending on the electricity source, particularly in the West Coast of the US, the electricity is getting much cleaner and cleaner. It's more clean than not these days. And it's continuing to travel in that direction where it gets more and more clean. That the benefits of switching to an electric appliance, both for climate and for health purposes, are even stronger, right? The argument just keeps getting stronger and stronger for it. And we've talked about that in terms of air pollution and in terms of climate. And I think that's the important thing to think about going forward, and just to really understand the ways in which the climate and the health impacts of switching to clean energy go hand in hand. In order to keep up on these kinds of things, I think one of the things that you can do, we talked about it today also, is just getting a indoor air monitor. There's all kinds of low cost sensors out there, and getting the networks of low cost air monitors built up will really help understand the patterns of pollution and better understand what is going forward and what we're going to be able to how we can reduce air pollution in these switching over to clean energy.
Yeah, there's that company Purple Air that has those sensors that have like a larger network. They're an interesting company. Good people over there for sure. Dr. Stevens, do you have anything to add on that one?
Not much. I think I'm not terribly familiar with the LEED standards, but I think there are aspects of the type of cleaners and the type of low emission materials that are required for it. And I think those are additional things that, again, I think one of the key things in addition to ventilation is reducing the emissions of everything. And so using low emission materials, low emission cleaners and things, I think would also be very important in improving indoor air quality.
Cool. Yeah, there's a lot of stuff like that available on the market. So yeah, we just got to keep our eyes out for it. I think that is now time to shift to questions from the audience. We've left a little space here. We've been getting several questions. ISSA, can you send me the questions so far? And I can pick one to ask first. Or wait, no, I think I have one to ask first, actually. Let's see here. Oh, yes. If I were to pay attention to only one indoor air pollutant, is there one that would be the most useful to track? If I'm looking at all these different monitors and whatnot, is there one air pollutant that I should be paying most attention to?
It's hard to pick one. I guess that you can monitor. Yeah, I think it'd be tough to pick one. I think, nitrogen oxides, as Eric probably would say, would be very important, just because of a variety of sources. In addition, I think besides combustion, there are also surface sources of nitrogen oxides that maintain a constant level of nitrogen oxides in your house, even if your stoves aren't being used. We found that during home chem, that after cooking episodes, the nitrous acid concentrations would be elevated during the episode, but then it would take a while for them to go down, because there's this known surface equilibrium with nitrogen nitrates on surfaces and things like that. Again, one molecule, it's tough to pick. I think VOC emissions you need, to reduce, but there are so many of them. I don't know if there's any one molecule. Ozone as well is important to monitor, although in general it's lower in your house, but as we've seen, even relatively low levels of ozone, 5, 10 ppb, which is much lower than the 50 to 70 ppb you may see outside, can still create reactions inside. So yeah, that's a tough question.
Is there a reliable way to reduce ozone, or to I thought that was a question that went by, or to help to, especially in like a larger building, to help prevent it from coming in outside? I mean, I know this, like, when there's carbon filtration kind of the only thing.
Yeah, I'm not an expert on this, but I know activated carbon, I think, will remove ozone. There may be other types of filters that can remove ozone. But I think activated carbon may be the most common.
And yeah, I feel, and it's also very cheap and available. Around one more question about devices and sensors and whatnot. Is it best just to get a full spectrum solution? I mean, I know that there's that company Aware that has a sensor that does, humidity and carbon dioxide and VOCs and temperature and some other things like that. So is it good just to get like a full spectrum sensor kind of thing, or could you, just monitor the carbon dioxide to know how ventilation is going? Do you have any comments on that, either of you?
I can chime in real quick there. I think that I haven't played around too much with these full suite sensors as we're referring to, but I do think that they do prove to be handy, even if you can't directly measure NOx emissions, for instance. What you can measure pretty easily nowadays is carbon dioxide, as you mentioned, and we know that the carbon dioxide and the NOx emissions are correlated. So if you're cooking and you see a big spike in carbon dioxide, you can also assume that you're getting a spike in NOx, even if you're not measuring that directly. And then you can make adjustments to see, like what the best ventilation scenario is. Like, does turning my vent hood actually reduce the spike in carbon dioxide that I get from my gas stove? If so, then I'm also probably reducing the NOx emissions or the NOx concentrations in my kitchen while I'm cooking. If I'm not seeing much of a reduction, then maybe I need to do something else, like open a window or turn a fan on to help circulate the air and get it ventilated outside. So in that way, and especially while you're cooking, that's a good way to help monitor the progress of reducing indoor air pollution, even if you're not directly measuring things like NOx, which are a bit trickier and more expensive to measure.
Great. We have another question here. Somebody asked, they are a carpet upholstery and tile cleaner. So they go in and clean people's houses. So they're wondering how their cleaning visits or lack of a cleaning visit could affect the air quality in the home. Do you have anything, without knowing what chemicals they're using, would you be able to comment on that?
Well, I guess yeah, I don't know what chemicals are used. If you're using something that gives it a nice pine or citrus smell, then that would be indicative of reactive VOCs for sure. I guess I would say, again, ventilate while you're cleaning to help reduce some of these impacts is probably the best thing to do.
And the same person asks, so a lot of he goes and sees clients and their houses are filled with Glade plugins. How can you recommend that they make their house smell better without adding things? I mean, is it using baking soda to reduce smells? I mean, you want to remove the smells as opposed to add things to cover it up, right?
Yeah, you're getting outside of my expertise here about some. What are things that smell nice but are unreactive? Yeah, I don't know. I think there are better ways to reduce odors than putting in these Glade things, or even other aspects. Again, ventilation probably is maybe the easiest way to reduce the smell, but a lot of people like the pine smell and everything like that. That's why my wife was always using these essential oil vaporizers and things. But I think just by opening the window now, she can get a nice clean non-smell, if you will, but get rid of odors just by improving the ventilation.
Great. And then we have a fourth question. It's a little bit about filtration, so I'm not 100% sure you can speak to it, but I will ask anyway. Just how concerned should we be about particle size, considering the claims of HEPA manufacturers? Like, you always see that 0.3, 99.97% on the HEPA claim, on the HEPA box. Does that really mean that they're going to be taking particles out that size? Should you be concerned about particles that size? Is there a way to look at those filters that is a little bit more informative? Yeah, you may not. It might not be clear. I know from being in the purification industry that all filters will capture all particles at some rate. But the smaller the particle, the more difficult it will be for the filter to capture it, obviously, until it gets so small that, like a size of an individual molecule, that it won't actually stick to the filter and it'll just blow on through. But for the most part, when you hear about a particle, it will be captured by a HEPA filter at some efficiency. Hold on, look for another question here. So Dr. Stevens, when you talk about these reactions, is this kind of the same thing for disinfectant sprays, for shower cleaners, for window cleaners? I mean, is ammonia the same impact as limonene?
Probably not the same, but there are other cleaners that have different chemistry. So during home chem, we did a lot of bleach cleaning, and that produces basically chlorinated compounds and chlorine that, in the presence of light and sunlight just from a window, could initiate some rapid chemistry as well. But there are some cleaners that we did not see any type of chemical reactions because they just did not have the same monoterpene type emissions. But we've started doing some studies where we're looking at other what we call personal care products, and we're still analyzing them. So we last summer did experiments with people doing washing their hair and using hair cleaners and hairspray and other things. This is also kind of important for outdoor air, as we're finding that as emissions from cars have been reduced to help improve outdoor air quality, emissions of cleaning products and personal care products are now becoming relatively more important in many urban areas. And so we've started studying what are some of the reactive compounds in various personal care products. And so a lot of them are similar. Some of them have different types of emissions and different reactivities. But a lot of them are again, these monoterpene type compounds that then get emitted both indoors as well as then are emitted outdoors, which then impact outdoor air quality.
So just for non-science people, so in general, a monoterpene usually is usually a plant-derived compound that has a specific smell and it's usually the fragrance component of a lot of these things, right?
Yeah, as far as I am aware, yes. These are often they're natural compounds that are emitted by a variety of tree species and vegetation. But the key is, outdoors they react with ozone, which in some sense is a good thing because it helps keep ozone levels low. But when you mix it in with nitrogen oxides and other VOCs, then again they can lead to the particle formation and in indoor air, the concentrations we find are much higher than outdoors, and so then you get the enhanced reactivity occurring indoors.
That is, yeah, it's good to know, but concerning. This is a quick question for Eric. What was the name of that article you published dealing with the with gas burning?
It is called Methane and NOx Emissions from Residential Stoves in California. It was published in Environmental Science and Technology in January of this year.
It's a good paper. I do recommend it to anybody who likes to read scientific papers. Let's see here. It's an interesting question. When you're using natural gas, is it the natural gas or burning off, or is it the methyl mercaptan that is added to the other items to detect leaks that cause the extra emissions and the leakage, or is it just kind of everything that's in the pipe there?
Are we talking about while it's burning or while it's or just unburned emissions? Do you know?
I think it's
I can talk about both.
Yeah.
Yeah. While it's burning, most of the pollution that's coming from the gas is attributed to the combustion byproducts. So the NOx emissions are a byproduct of combustion. Basically, the high heat and excess oxygen will be able to oxidize the nitrogen in the air in order to form the NOx from the burner. So that's the main thing that we're concerned about. The mercaptans, I can just talk about that real quick. So all gas companies will add some form of mercaptan to the gas. That's what gives it's the rotten egg smell or that sulfury smell that you get when you smell unburned gas. And the point of doing that is to detect unburned leaks because, as I said before, methane in a high enough concentration is explosive. So especially in a confined space, if you're smelling that smell, it's important to immediately leave the area and then call the gas company to come and investigate. Because if you can smell it in your kitchen or anywhere in your house, it's very likely you have a gas leak, and that can be dangerous at a concentration where you can smell it. In my paper, I also said that gas stoves. We found that most gas stoves emit methane even while they're off. In natural gas, even while they're off. Most of these stoves that we measured were not able to be detected by smell. So their concentrations were low enough that there was enough methane that we could quantify it using our analyzers. But it wasn't enough to be an explosion hazard.
That's very interesting to learn. I'm trying to see if we have any more questions here. A question about air purifiers. Can air purifiers help to reduce indoor pollutants? If yes, by how much? That's going to very much depend on the size of the room and the room, how big the air purifier says of a room it says it can handle. If it says it can handle 1,000 square feet, that's obviously going to work a little differently in a 2,000 square foot room. I get asked this question a lot as the head of science content, and it is very, very difficult to know exactly how long air cleaned by an air purifier will stick around. Everybody's house has different air exchange rates with outside. It's a relatively difficult question to answer, and it is unique to each person's circumstances. So the best way is just to get a unit and see if it works for you, and if not, send it back. So someone was asked, would running a hydroxyl generator affect the IAQ? If so, how? I think I know the answer, but I would like Dr. Stevens to say something.
Yeah, so we're actually looking at some of these hydroxyl radical generators. In general, some of them don't produce enough hydroxyl radicals to do anything. If you measure really close to the source, you could see some radical production, but then we put it in a room and we just turned it on and turned it off to see if we saw any changes in VOC emissions or concentrations. And we're still working on it, but we really didn't see anything for this particular cleaner. In general, we don't recommend cleaners that add oxidants to the atmosphere for cleaning, because again, you're just maybe creating oxygenated products that are worse than the original VOC themselves. So again, a hydroxyl radical generator is going to try to remove the VOCs by reacting with them, but it's going to produce oxygenated products, which then could form particles or could be more toxic than the VOCs originally themselves. So same with ozone generators that could do it, just as we've demonstrated in the paper. I just put a link in the chat to our ozonolysis paper. Again, adding ozone, it may remove the VOC that has the odor, but you may be producing oxygenated products, which may be as harmful or maybe more harmful. So yeah, I think the community just does not recommend using these reactive air cleaners.
Yeah, someone asked like what products are those? I mean, there's a lot of them. There's like bipolar ionization generators, which make like a little plasma thing that's supposed to generate oxidants that will kind of break down things in the air. There's ozone generators, there's hydroxyl generators. There's a lot of these different products that will release oxidants into the air with the goal of kind of breaking things down in the air. But like Dr. Stevens was saying, if it's breaking down in the air, that means you're inhaling whatever's happening, and that's probably not good for you. So unless we have any more questions, I think that we're going to end about 2 minutes early. Any final remarks from either panelist, or do you guys enjoy your time here already?
No, thank you. Very interesting. Thank you for having me.
For sure.
Yeah, likewise. Thank you so much for putting this together and for having me as a panelist.
For sure. And thank you both for attending, and thanks to everybody for listening, and congratulations to our 2 winners. And please share this presentation with anybody who you think might be able to get something out of it. And I will see everybody later.
Thank you so much.